Hello, ladies and gentlemen, this is Mrs. G. I am going to be talking to you today about the concept of surface area. Okay, so be aware that when we do measurements with three-dimensional shapes, we often talk about either surface area or volume. Okay, maybe you've heard of volume from last year. Now, the volume is basically the whole space inside of your figure. So, it's the water inside of your cup here. Okay, it's all of the three-dimensional space that's in the inside of a shape. That's actually not what we're talking about today. We're going to talk about something different called surface area. So when you think of surface area, what I want you to think about is, kind of the wrapping paper on a box. Okay, if this is the box and you were going to try and kind of put wrapping paper on the outside, how much paper would you need to encase that entire figure? And we talked about cubes. One way to think about it is think about the net. Okay, if you were to peel that shape open, what would it take to cover it back up again? Well, last time we had class, we talked about drawing the nets of our figures. So that's more or less how we're going to think about the concept of surface area today. If you were to wrap around the outside, basically adding up the area of all of the faces. So you could add this square to this square, to this square, to this square, the area of those squares. The area, the base times the height. If you add up, for example, in this case, all 6 of those squares, you would have the total surface area of the shape. Okay, and what we're going to start off talking today about is rectangular prisms. Okay, a rectangular prism is basically, you might call it a cuboid, but it is kind of like a box, okay? It's going to have 6 faces. You might think about like your math textbook, okay? It has 6 basic rectangles that make it up. You're going to have a top and a bottom rectangle, okay? And the top and the bottom are going to be the exact same rectangle, right? You're going to have the side rectangles. You're going to have the left side and the right side of that box, and those are going to be the exact same rectangle. And then lastly, I guess in this case would be the largest ones, you're going to have the front rectangle and the back rectangle. Okay, and those rectangles are also basically the same to each other. Okay, so that's how we're going to deal with surface area today. I'm not going to give you any sort of long, complicated formulas. We just have to visualize it as the separate faces, we call them. Okay, so the face is like if you were to think about this cube, like this, one of the faces is like this. So if we think about all the, maybe you might say the sides, kind of, we're going to add them up kind of separately, but then together come up with a total surface area. Okay, so let's start with a rectangular prism. Okay, this is more or less what I am talking to you guys today about as far as the formula for the surface area of a rectangular prism. Okay, all you have to do is think about which rectangles are the same and then add them up. So again, we have the right side and the left side. These 2 blue rectangles are the same rectangle. So if you find the area, if you find the area of one and you multiply it by 2, then you're going to get both the left and the right side. Same thing with the top and the bottom. If you find the area of one of those red rectangles, then you multiply it by 2, well, then you'll have both of them. Okay, so the same with the front and the back. That's what these green ones are. Okay, if you find the area of one of the green rectangles and you multiply it by 2, well, then you're going to get the area of both of the green rectangles. And if you add all of those areas together, you're going to get the surface area of the whole shape. If you were trying to wrap that entire box up as someone's Christmas present, how much wrapping would you need? Okay, so I've written all over this, but guys and girls, I would like you guys to kind of copy this into your notes as far as the formula. Okay, so it might take a bit of time. Don't feel like you have to make your figures perfect, but you might want to kind of draw this idea of a rectangular prism. Remember last time we drew a rectangle, we drew kind of these diagonals, and we drew the sides, or you draw a rectangle, you copy paste, you do this sort of thing. And if you want, You could probably go from this diagram to that diagram, but I think a little bit of color might help. So feel free, please do pause the video right now and try and get a visual understanding of the surfaces of a rectangular prism. Okay, we have two left and right sides. We have two top and bottom sides. We have two front and back sides. Okay, get that in your notes, please. All right, hopefully you're back from writing that down. Let's look at what this means as far as some problems, some actual example problems. Okay, I have printed off cute little pieces of paper that look like this. So you don't have to copy this down into your notebook. All you have to do is kind of fill in the writing here that we're going to do. So if you don't have this little slip of paper, please do ask your teacher. If you need to pause and glue it in, that's okay too. But what we're going to do here, folks, is we're going to draw pictures for our formulas. I'm going to use some color here. Let's just start with this first rectangle that's in the front. Okay, actually, orange. Okay, so this is my orange rectangle. This orange rectangle, what I'm going to do here is I'm going to draw a picture of it. And then with my picture, I'm going to write down the dimensions. That orange rectangle, hopefully you can see, is 2 by 3. And how many are there? There's actually 2 of them, because there's an orange one back here that matches that orange one there. So the way that I kind of write that down is I write a big 2 in front, 2 times. All right, from there, let's add other rectangles that you might see. You might see that here, we have this pink one here. Okay, that one along the side. So what I'm going to do is I'm going to draw a picture of that one here. Okay, it doesn't really matter if your picture is perfect. It's just a rectangle. That rectangle, hopefully you can see, is 6 by 2, because that comes over here. And remember, we don't just have one of those pink ones. We have another one over there. Okay, so that rectangle is 6 by 2. And I put a big 2 in front. That's a little bit messy. Let me see if I can clean it up a little bit. I put a big 2 in front because there are 2 of them, right? Okay, there's the left side and the right side. And then last but not least, let's find a new fun color here. How about green? This rectangle here, okay, hopefully you can see there that it has dimensions of 6 and 3. Okay, so I have another rectangle here that's 3 by 6, and again, I have 2 of them. I'm going to put a big 2 in front. So that's more or less my formula, and believe it or not, that's the hardest part. Just kind of breaking up our 3-dimensional figure into all of its faces, okay, all of the sides. From there, you just want to think of how do you find the area of a rectangle. Okay, the area of a rectangle is simply base times height. So here we have 2 times the 2 dimensions, base times height. This 2 here simply comes from the fact that there are 2 rectangles. I just kind of bring that down. Okay, my left and my right sides, my pink ones. Okay, that's going to be 2 times 6. Okay, my green one, that's going to be, 2 times 3 times 6. Now, if you want to just kind of follow along and make sense of it, just listen and take it in. That's not a bad idea. If you want to pause periodically and fill this in as I go, that's okay too. Okay, whatever works for you. So now all I really have to do is follow my order of operations, either PEMDAS or BEDMAS, whatever you want to call it. But what really needs to happen, ladies and gentlemen, is just make sure that we always multiply before we add. So 2 times 2 times 3, well, this part's going to be 4, times another 3 makes 12, plus this one here should be 4 times 6 makes 24, plus the first 2 make 6, and then times another 6 is going to make 36. Okay, so remember, we're doing multiplying, and then we're adding. I'm going to pull those 2 together. That's going to give me 36 plus 36. My final answer, my surface area of this whole figure over here, is 72. The units are feet. So therefore, it's feet squared, because, ladies and gentlemen, you are finding an area. The area has, it's 2-dimensional, so our label is feet squared. And that, ladies and gentlemen, is all the faces of that rectangular prism added together. If that didn't make sense to you, feel free to go back and pause the video, watch the pieces of it that, felt confusing. Maybe keep plugging along and see if as you watch the next figures, it starts to make a little bit more sense. This is not an easy concept. Okay, this is not something that's going to like come to you right away. So give yourself some time to really digest it. Let's go to our next figure. Okay, our next figure is a triangular prism. Okay, remember a triangular prism is made up of a triangle on either base, so kind of the top and the bottom are triangles, and then those triangles are connected by some rectangles. Okay, if you want to take a look at the figures that I actually have in class, this would be the red one. Okay, this is a triangular prism. Again, this is more or less your formula right here. Triangular prism is made up of two rectangles. I'm sorry, two triangles, and three rectangles. And one there in the back. Now, it's possible that these rectangles are exactly the same, but it's also possible that they're not. So you might want to understand that this could also, or be two triangles plus a separate rectangle, plus a separate rectangle, plus a separate rectangle. Because maybe, just maybe, those are different dimensions. I'll give you an example of that in a second so it makes sense. Okay, so again, try and give yourself a little picture of this general idea in your notes. Feel free to take some time and add some color, and then come back to me. All right, ladies and gentlemen, hope you're back. You have drawn a bit of kind of the formula for a triangular prism. Let's look at an actual problem. Okay, so again, I have the, oopsie, sorry. I have this printed out for you on a little sheet of paper. Make sure you get it and glue it in. So this triangular prism here, let's start with maybe the easiest pieces to see. Let's start with the triangles. Okay, it has a triangle on the top and a triangle on the bottom. Okay, I've done those in pink. So here you have two triangles. Maybe you notice something interesting. Okay, you really want to look for that right angle. Remember, a triangle, it's not a very good picture. Triangle's area is found by base times height divided by 2. The base and the height have to be perpendicular. Have to be. That's a rule. So make sure you're always looking for this little perpendicular, that little right angle square. So the base and the height of that triangle, I hope you can see, are 3 and 4. The 5 is not necessary to finding the area of that triangle. We'll need it later, but we don't actually need it for the triangle. Okay, so times in there. Our triangles are the same. The top and bottom triangles are the same, and they are 3 by 4. Let's take a look at the rectangles. We have a rectangle here. Let's just start with any of them. So that one's going to be yellow. Maybe we'll make it orange. Okay, and so that rectangle there, can you see the dimensions? What do you think? That is a rectangle. That is 6 by 3. All right, we have another one. Let's just grab this one here. We have this rectangle here, kind of the other side that's facing us. Hopefully you can see that rectangle is definitely 4 here. Now what's interesting is this 6 is going to be the height all the way up. All 3 of those green lines are going to be 6. So I have another triangle. I'm using green here, and that one's 4 by 6. Hopefully, last but not least, you can see that there's one more triangle in the back. Let me clean things up a little bit. I'm sorry, not triangle. Did I say the wrong word? Rectangle. There's a rectangle in the back there, this blue one. That rectangle, hopefully you can see, is 6 by 5. So I have one more. That's 6 by 5. So I drew out all 3 separate rectangles because they're not the same. They have different dimensions. Okay, the fact that here's a 3, here's a 4, and there's a 5 means that the rectangles themselves have different dimensions. This blue one here has a 3 and a 6 as its base and its height. But, this one here, this orange one, is 4 by 6. Okay, so that's why I drew these out here, because they're separate as far as their dimensions. They're not the same exact rectangle. Again, like I said before, this is the hardest part, really breaking it up into the separate pieces and the separate faces. That's tough. So from here on out, it's mostly just making sure we understand the formulas. A triangle is base times height divided by 2, and then we have 3 rectangles that are all base times height. The triangles are going to be, remember I'm just bringing this 2 along because there's 2 triangles, those pink ones. Let's see here, they are going to be, oh, it's a good thing I wrote it up here because I lost track. 4 by 3, right? 4 times 3 divided by 2, plus my orange rectangle is 3 times 6. My green rectangle is 4 by 6, and my blue rectangle is 5 by 6. All of those separate surface areas we're just going to add together. Now what's interesting here is this 2 cancels with that 2. If you multiply by 2 but then divide by 2, you're going to get back to where you started from. So, I mean, you could work it out if you wanted to. If that's tricky to you, what you can see is, there we go. What you can see here, hopefully, is that 4 times 3 is 12. When you divide that by 2, you get 6. And when you multiply by 2, you get 12 again. So it's the same as if you just did 4 times 3. So 12 plus 18 plus 24 plus 30. Okay, then I'm just doing my order of operations. I'm just doing my BEDMAS here, just making sure to do my multiplying before I do my adding. Here I have 30 plus another 30, that's going to make 60, plus my 24. Final answer of 84. If you don't have a unit, you can just write the word units squared. Okay, so take a moment, feel free, copy that down, go back and just kind of read it through and make sure it makes sense. Write down any questions you might have. I'm happy to help you out when I get back, okay? Look it over again. Feel free to watch pieces and parts you didn't understand. But let's move on to our last and final shape for today. Our last and final shape from today is a cylinder. Okay, a cylinder is simply made up of 2 circles and 1 rectangle. Okay, the 2 circles are here, the top and the bottom. And then what happens, what's interesting, is if you were to unravel this piece here, really kind of pull it open, kind of slice it on one side and flay it open, you're going to actually have a rectangle shape. Okay, that's going to be one of the yellow figures I have in class if you want to take a look at it. So, again, please feel free, draw yourself a circle, and maybe just something, oopsie, draw yourself a cylinder, not a circle, draw yourself a cylinder, and then you have this idea of it's 2 circles and 1 rectangle. Okay, get that in your notes and come on back. All right, hopefully you have a little bit of this diagram in your notes. Now, I actually want to add some more information before we move on. The cylinder is really the trickiest one of today because there's a piece of information here that actually isn't given to you, the base of the rectangle. Okay, if you remember, this rectangle comes from opening up the side kind of portion. I guess it's more like the height, but yeah, the pieces basically that are not the 2 circles. If you open that up, you're going to get a rectangle. Okay, they're going to tell you the height. Okay, here, they're going to tell you that the height of this rectangle here is whatever they tell you the height of the cylinder. But the base is tricky. And I would just write this in your notes. Write it on your formulas cheat sheet. This piece, if you remember that it has to kind of perfectly line up with that circle. That length here, this pink part, is actually the same thing as the circumference of the circle. Okay, please write that down. And also note next to it that the circumference formula is going to be simply pi times diameter. Okay, so to find this pink length here, you have to find pi times diameter. What would be the circumference of the circle? Just jot it down, put it on your cheat sheet so you have it, and just refer back to it when you're trying to find the surface area of a cylinder, okay? Let's do an example problem. See if you can see this working out as, you know, some actual math here. Okay, so I have, again, this cylinder here. Okay, the radius, they tell me here, okay, that 3 is the radius of my circle. This 10 is actually the height of the cylinder, because most of the time you want to visualize your shape like this. Okay, your cylinder is more like a soda can that's standing up and down. Okay, the 10 would go there, and then the radius of 3 is there. Okay, so let's first just start at the beginning and start splitting it up. Okay, again, oops, I'm sorry, I want to highlight a little bit. We have two circles. We have a circle here, we have a circle there. Okay, so the outer edge of the outer faces of my cylinder is made up of two circles. Draw a nice big circle. Okay, plus just this one rectangle that's here when you open up that side piece. Okay, so that is one rectangle. Before we go on, let's add the dimensions that we need. To find the area of a circle, that you're going to need pi r squared. That's just the formula for the area of a circle. Multiply pi times the radius squared. So first we do the radius squared, and then we multiply by 3.14. R is 3. Let's just add a little 3 in there to know that that's the radius. Now, this 10, okay, this 10 here actually corresponds to the height. It corresponds to the height of that rectangle because you're almost taking this cylinder and kind of turning it 90 degrees. So it's now this shape, and then the 10 is there. Okay, so visualize kind of picking it up and, and spinning it a little bit. This part is the trickiest part of today. This piece here. Or I guess that piece there. Doesn't really matter if it's on the top or the bottom. That length there is equal to the circumference of the circle. So remember, pi times diameter. In this case, it's going to be 3.14 multiplied by the diameter. So if r, think about it, if r equals 3, if the radius equals 3, the diameter has to go all the way across. So then the diameter is 6. Does that make sense? It's twice because it goes all the way across. So now let's just fill in what we need. I like to take a step in between here. So 2 times pi r squared, because you have two circles. The formula for a circle is pi r squared for the area, times, and plus base times height, because this one is a rectangle. So base times height. 2 times 3.14 times radius, or here, of 3 squared, 3 times 3, plus the base, which is this interesting thing here, 3.14 times 6 times the height, which is 10. Okay, now again, you're just going to need a calculator. I'm going to have to get out my calculator. Again, just make sure you're doing the right order of operations. We have to do this part first, the exponent or indice. So I'm just going to punch in my calculator 9 times 3.14 times 2 to give me this portion here. And that is 56.52. Okay, for this part here, I think I can kind of mentally do 6 times 10, so that's 60. 60 times 3.14 gives me 188.4. I add those two together, 56.52. And your final answer there is 244.92. Again, if you don't actually have units in your diagram, you just write units squared. Okay, so I know there was a lot. Please feel free to go back. All right, be aware this portion here is just your circle. That's a circle. There's 2 of them. That's why you have a 2 in front. The base times the height is the rectangle. What's difficult here is, again, the base length of that rectangle is equal to the circumference of the circle. If you don't really believe me, go ahead and find our picture of our circumference. It's an orange one. It's an orange one of our diagrams. And you can kind of, play with it and touch it and kind of see how visually all that works. All right, if you're ready, what I want you to do for homework is 3 questions. It's this worksheet here. Okay, if you don't have it, your teacher will give it to you. Okay, use a calculator. Definitely use a calculator. Use 3.14 for pi and try it. Okay, give it a go. If you're really feeling stuck, I made a video that explains these questions. It's really meant to do when you're done. Okay, so when you're done with these 3 questions, I made you guys a video so that you could see how to go about doing the problems. Okay, it's on the VLE. It's just probably underneath this video right in the poster you're looking at right now. Okay, so give it a try. Again, don't be afraid to use some color. I think these are much easier if you have some highlighters. So you got a pink rectangle, and then you can say, all right, well, I have, 2 of the pink rectangles plus maybe 2 of your orange rectangles. Okay. And then you have on the top and bottom, pick another color. You have green. You have 2 of the green rectangles. All you have to do now is find the dimensions of those rectangles, label them here on your picture, and then follow BEDMAS or PEMDAS.